Welcome to another physics class. We want to continue with our topic, that is terms used in motion. In our last lesson, we discussed on speed. Now let's move to velocity. We have the various definition of velocity. Definition of velocity. 1. Velocity is the speed of an object in a specified direction. That's the first definition. 2. We can also say velocity is the distance traveled per unit time in a specified direction. The distance traveled per unit time in a specified direction. Note, by the time we use speed and velocity, or distance and velocity together, then we need to add in a specified direction, because speed and distance are scalar quantity, while velocity on its own is a vector quantity. So another definition, number 3, we can say velocity is the rate of change in displacement. Rate of change in displacement, that is rate, already time is there. So we can say velocity rate of change of displacement. In another sense, that's number 4, we can also say velocity is the rate of change in distance in a specified direction. In a specified direction. Point, it can also be defined as velocity is the change in displacement per time taken. Change in displacement per time taken. And let's have one more. Velocity is the ratio of change in displacement to time taken. Depending on whichever one you remember in any exam, especially because of objective questions. They can write all the following are correct definition of velocity, except then you need to know all these definitions very well. Now, the next thing is types of velocity. Types of velocity. 1. We have average velocity. Velocity. 2. Uniform velocity. 3. Non-uniform velocity, or you call it variable velocity. 4. Instantaneous velocity. Let's take it one after the other. 1. Average velocity. Average velocity is the total displacement per unit time. Total displacement per unit time. Or, according to all these definitions, you can take anyone to define it. Just make sure you add total. Now, if you want to use distance instead of displacement, then you need to add in a specified direction. Anywhere you remove this displacement under velocity, then you need to add in a specified direction. So, average velocity is total displacement per unit time. That is, average velocity is equal to total displacement over total time taken. That is, V is equal to D over T. That is for average velocity. Number 2, uniform velocity. Uniform velocity occur when the rate of change in displacement is constant. When the rate of change in displacement is constant, or as I said the other time, from all the definition, if you remove displacement, you want to put distance, it means rate of change of distance in a specified direction is constant. Then you have uniform velocity. That is, as the displacement is increasing, time also will be increasing in the same order. Number 3, non-uniform velocity. Don't forget, I said this one also can be variable velocity. This one means is occur occurred when the rate of displacement is not constant. When the rate of displacement is not constant, that is, when the rate at which displacement is occur is not at the same time with the time taken, then we can now say we have non-uniform velocity. Now the next thing is instantaneous velocity. This one use the same term, that is displacement and rate. The instantaneous velocity means the rate of change in displacement at short time interval. That is, mean the rate of change of displacement at short time interval. That's what we mean by instantaneous velocity. And this one means instantaneous velocity is equal to delta D over delta T. That is, change in displacement over change in time taken. So these are for velocity. And at the same time, velocity, either instantaneous velocity or any other velocity, like that of speed, velocity is measured with speedometer. Velocity measured with speedometer. Now, let's see the differences between speed and velocity. Number one, speed is the rate of change in distance, while velocity is rate of change in distance in a specified direction. That is, if we want to go by definition to differentiate between the two quantities. Number two, speed is a scalar quantity, while velocity is a vector quantity. And don't forget, we define both scalar and vector quantity in our last lesson. Again, number three, as a scalar quantity, speed does not require any direction. But under velocity require direction. Next thing is similarity between the two. Similarity between speed and velocity. One, both have the same unit as meter per second. Number two, both are derived quantities. Both are derived quantities. These are the two major similarities between the two quantities. Next term is acceleration. What is acceleration? It simply means the time rate of increase in velocity. That is, when there is increase in velocity, definitely there must be acceleration. Let's write it. Acceleration is the time rate of increase in velocity. Time rate of increase in velocity. Let's take this one as the first definition of acceleration. Again, number two, acceleration is the time rate of increase in speed in a specified direction. Why adding a specified direction is speed is a scalar quantity, acceleration is a vector quantity. Let's add one more definition. Acceleration is the ratio of increase in velocity to time taken. Increase in velocity to time taken. That's the definition we can have for acceleration for now. Now, that is, we can now say that acceleration is equal to increase in velocity over time taken. That is, A is equal to delta V over T. That is the mathematical relation for. The next thing is types of acceleration. One, we have uniform acceleration. Two, non-uniform non-uniform acceleration. Then 3, instantaneous acceleration. Let's take them one after the other. 1, uniform acceleration. Uniform acceleration occur when the time rate of increase in velocity is constant. When the time rate of increase in velocity is constant, we have what we call uniform acceleration. That is, as velocity is increasing, time also is increasing. Then we have uniform acceleration. Number 2, non-uniform acceleration. Or another word for this one is variable acceleration. And this one occurred when the time rate of increase in velocity is not constant. As in, when the rate at which velocity is increasing is not at the same time as that of time, then we have no uniform acceleration. The next one is 3, instantaneous acceleration. This one is the time rate of increase in velocity at short time interval. The time rate of increase in velocity at short time interval is what we mean by instantaneous acceleration. The instantaneous acceleration A is equal to delta V over delta T, where delta V is equal to V minus U, and the word delta V is equal to increase in velocity. V is final velocity, while U is initial velocity. Note the unit of acceleration. The unit of acceleration is meter per second square. We are familiar with this one before in our former lesson. and at the same time, acceleration is a vector quantity. Is deceleration or retardation. This one is just the opposite of acceleration. That is, as in the case of acceleration, which is the time rate of increase in velocity, deceleration is the time rate of decrease in velocity. That is, deceleration is the time rate of decrease in velocity. While acceleration is positive, deceleration is negative. That is, during calculation, the value for acceleration will be positive value, that of deceleration will be negative value. Then the next one is types of deceleration. Under the types of deceleration, we have the following types: uniform deceleration, non-uniform deceleration, and instantaneous deceleration. To define each, number one, uniform deceleration. This one occur when the time rate of decrease in velocity, time rate of decrease in velocity is constant. That is deceleration. Why? Non-uniform deceleration, non-uniform deceleration, non-uniform, you can call it variable deceleration. This one occur when the time rate of decrease in velocity is not constant. Then number three, instantaneous deceleration. Instantaneous deceleration is the time rate of decrease in velocity at short time interval, like that of acceleration. Deceleration, instantaneous deceleration is equal to the v over the t. Don't forget, the other time we've said the v is v minus u. Now, from this one, the v equal to, instead of increase now, it will be decrease in velocity while v is final velocity and u is initial velocity. Note, both the instantaneous acceleration and instantaneous deceleration, or in short, acceleration and deceleration use the same symbol. As I said the other time, what differentiates between them is the value during the calculation. Acceleration will be positive, deceleration will be negative. They take the same unit. That's similarity between them. Acceleration and deceleration take the same unit, and the unit is meter per second square. Meter per second square. Now, this is convenient point to stop for today. In our next video, we are going to look at how we can use graph to represent all these the terms in motion that we have looked at. And as I said in the beginning, if you are new to this channel, please don't forget to like, share, and subscribe so that when I post new video, you'll be able to get it in time. Thank you.